And with that, I would like to hand the floor over to your host for this series, Puneet Suppal. Puneet, you now have the floor.
Thank you. Good morning, good afternoon, and good evening. My name is Puneet Suppal, and I welcome you to this edition of our webinar series called Innovation Delivered. The topic today, as was just announced, is addressing next-gen Industry 4.0 manufacturing needs with a unified IT/OT platform. In a world where every enterprise seeks competitive advantage through digital transformation, there is a revolution taking place in the realm of manufacturing as well. Manufacturing stands to gain significantly from game-changing IoT solutions. To talk about the subject and to share impactful solutions today, we have with us two amazing speakers. Sam Lakundi, who is the VP of Innovations at BMC Software, is responsible for leading new cutting-edge innovations at BMC with a talented team of architects and engineers. His mission is to inform, inspire, and influence BMC customers via game-changing design and technologies. Sam is a technology thought leader and change agent with a proven track record of achievements in envisioning and creating new technologies and applying them to accelerate digital transformation with leading technologies like AI and big data. Our second speaker today is Bill Neiman, and he is currently a digital industrial analytics and commercial success leader in the greater Chicago area. As a manufacturing industry advisor, he represents Simcon Digital. Formerly, he was at GE Digital as digital industrial analytics leader with over 10 years of leadership in software and solution architecture. He has achieved important customer outcomes in predictive analytics deployment and integration. So folks, we have two great speakers, an amazing topic, and lots to talk about. So without further ado, let's hear it from Sam and Bill. Over to you, Sam.
Thank you, Puneet. And the next slide, please. So today's conversation is on what game-changing, changes are there in industrial manufacturing. Puneet, I'm not seeing the slide. So, the reason, the topic of this conversation is more focused on real use cases and how we as BMC Software as well as Simcon have a deep understanding of this business, and more importantly on the use cases that matter for the focus areas of manufacturing and industrial evolution. Next slide, please. I'm not seeing the slide, please.
Hidden costs of disconnected ITOT.
If you are moving the slides, Puneet, I cannot see them. So,
is this? Are you seeing a slide, or are you seeing no slide?
I'm not seeing anything. Well, why don't you continue on, Puneet, and then we'll have Bill talk and we'll figure it out.
Why don't I take this, Puneet? I'll talk about the hidden costs of disconnected IT and OT.
Go ahead, please.
Go ahead.
So many organizations may not realize that there are hidden costs of disconnected IT and OT. Well, there are upfront costs of changing the status quo. With IT/OT integration, organizations can actually respond faster, innovate easier, and differentiate to customers that want speed, quality, and simplicity from producers. So there are strategic costs in not integrating these functions. Across the integrated businesses, information and analytics can move with less friction amongst users, amongst the departments, and amongst plants, while all users gain real-time visibility to a single source of truth with an enterprise asset management application. So let's just review some of the statistics from people like McKinsey and Deloitte about the efficiency gains from using a unified ITOT platform. For example, increases in productivity have been recorded on the order of 20 to 30%. Increases in uptime have been observed of 30 to 40% as people move towards zero unplanned downtime, and having access to real-time information actually has been found to improve employee morale. Reducing defects in individual parts can be decreased by as much as 60% by having real-time visibility to the production applications, and reduced time to market has been achieved of 40 to 60% because there's less time required to translate the customer request into business ideas and into production. We go to the next slide, please. So let's consider in a little bit more detail some of the challenges in the existing approaches. So legacy systems that we see in the middle row, data silos, legacy systems, and lack of real-time visibility, they differ, these systems differ plant by plant. And then there are data silos where people tuck away data that gives them the most control in the organization. There'll be spreadsheets in one drawer and notes in another drawer, notebooks in another drawer. And this kind of makes the operation of the organization opaque in many ways. It results in a lack of real-time visibility to how things are running today, and also how users can leverage solutions from the past to solve problems that lie ahead or they're currently facing. On the operations side, every organization is working to reduce reactive approaches. They have been for years, and they want to expand preventive and predictive approaches because everyone knows reactive approaches are the slowest and most expensive. Your machines, your pumps, your motors, or any equipment can be continuously generating critical data that could prevent or could provide in-depth understanding of your plant health. This data could alert you to potential failures down the line. Data can be as simple as sound or vibrations coming from your motors, the status of various lamps or on your machines, or the amount of power being consumed. Depending on the value of your asset to your process, this can be used for either preventive or predictive maintenance decisions. In IT organizations, they're leveraging digital technologies to move from transaction-based systems that involve a lot of daily collection, retrieval, and modification to MIS approaches that automate more of the work to collect information for managers, but may simultaneously incur complexity that slows work and frustrates users. Evolution of digital support systems promises to compile information and data, integrate multiple variables, then generate alternate outcomes, all based on the organization's past and current variables. So the goal of real-time information with decision support shared across the organization is to reduce costs of repairs, increase productivity, improve capacity utilization by better planning across the enterprise. And it's hard to realize without information that's highly integrated across the organization. So with that discussion of the challenges in existing approaches, let me turn it back to Sam for the information on the next slide about BMC Helix IoT Edge application.
Thank you, Bill. So, so to address the problems that Bill mentioned, right? And Bill, thank you for articulating the problem and what the scenario is. BMC has been a company that has been creating software for the last 42 years. What we have done with the BMC Helix IoT Edge platform is provide the ability for us to not only work on software related to what we have done traditionally in IT, but also now address the challenges that are in operations. What are the challenges in operation? In lieu of what Bill said, the challenges are, how do you discover assets that come in? How do you collect information that is non-IT information? May it be maybe it be in a power plant, or maybe it be on a rig, maybe it be here in a manufacturing plant next to a furnace, next to a mixer, or what have you. So the BMC Helix IoT Edge platform allows a user not only to understand the value of how to connect to the IT systems, but also provide that ability to gather information from operations by discovering assets, by analyzing that asset, understanding its anomalies, providing remediation, and also integrating with the best of breed. And when integrating with the best of breed, that could be your PLC systems in your plant. It could be the DCS systems, right? Which is the distributed control systems in your plant. And these are varied, right? So you have multiple manufacturers. You could have Siemens as your PLC system. You could have Rockwell Automation as your DCS system. So the platform needs to have that unique ability to recognize various different back-end operating systems that exist in a manufacturing plant. And these these manufacturing systems need to be performing at different various temperatures, different conditions, and the platform needs to be able to not only actually collect the data, but also do things like edge processing, edge analysis. And this is what the BMC Helix IoT Edge platform does. We have taken our learnings that we have had in the last 42 years and now taken that and applied that to operational software. And this is the major differentiation between what BMC can offer and some other vendors who are only offering the operational part of this business. And the use cases that I'm going to talk about in the next slide, lend to that detail on how we actually pull this off. We can move to the next slide. On this slide is really what you see here is the use cases. In the use cases that we are really going to talk about, we are going to focus on all of the different use cases that you see here, right? It spans the gamut of what you're seeing here, right? Whether it's detecting anomalies that are happening, detecting changes that are happening in the manufacturing process, and manufacturing can be in the discrete manufacturing, or it could be in process manufacturing. The ability for us to address these various different use cases, and the use cases that I mentioned are, we have talked to customers who have told us everything from what they're creating in a plant, which will help us to analyze their production process, which is in pre-production and in post-production. And when we talk about manufacturing, there is a massive difference between process manufacturing and discrete manufacturing. So the platform needs to be able to understand and address the different needs and different variations of what the platform offers. And these use cases that you're seeing highlighted here are, address each different scenario for what you're trying to accomplish within your own manufacturing organization. We can move to the next slide. So, in this slide, what you're seeing here is, a snapshot of some of the demos that, we have done, right? So you see on the left-hand side is a water cooler system, and on the right-hand side is different examples of how we are doing the manufacturing process. So what we have done is we have taken the best of the ability of collecting, not only collecting the data, but also reporting on that data. And that reporting on that data is in a very visual fashion, right? So what you're seeing here is in the demo is the ability for us to showcase and understand how the data shows. And really what you're seeing here is different permutations of how we are presenting that data for the different use cases. Whether we show a schematic of the actual equipment that you're touching, and that equipment that you're touching basically is pulling information from the various backend systems, and then we're able to actually report based on those systems here. So here's on the bottom right, what you're seeing is a food processing plant that we are working with. In this scenario, what you're seeing here is the ability for us to pull that information and showcase this as the process is moving. There are different various things that happen within a manufacturing plant. I am able to pinpoint within the different processes, whether it's in the rolling process, whether it's the heat treatment process, or it's in the furnace, or it's in the stamping process, or the hammer process. So what we are able to do is take the schematic of your organization, whatever organization you're offering, in your plant, and we're able to create a digital twin of that, and we are then able to show and showcase different permutations of really what data is coming out and really what that entails. So these are some of the very small showcases that we are working with some of our customers to really showcase how we can bring the ability for us to bring operational data and IT data together. And the beauty of this is not only showing the operational data, but also then how do you take it and create service management? How do you actually go out and do service operations? These are the things that basically this demo showcases. Next slide.
So,
great. Bill?
Yeah, I think I'll take this one. Okay, Sam? So the idea of ITOT or integration really means that the organization evolves towards a single pane of glass where everyone in the organization can have a real-time view of the same version of business metrics and the data behind them. This is achieved with strategic organization of your apps and capabilities. For example, your enterprise asset management system to manage the entire life cycle of your physical assets. But as Sam just showed, this starts with a diverse suite of applications at the very base layer. And these applications will have may be well censored or they may be poorly censored. If they're poorly censored, there's nowadays an opportunity to add sensors to them so that information can be harvested from them in real time. Above those set of applications, you need to have the ability to interact with them in real time, harvest the information at 1 second, 2 second intervals through PLC RTU technology, smart meters, smart sensors, and into your historians. And then normally from there, you'll move it into edge devices, one or more edge devices in your facility. And those edge devices, typically if there are more than one, you need to manage them as a group and take the data from all these sensors, these edge devices, orchestrate that data into a workflow that works plant by plant across your entire organization. So the goal is to have frictionless connectivity from the machine to the plant to the corporate workflow, from edge applications at the plant to cloud applications at the corporate level. Data needs to be collected efficiently from these wired and wireless sensors. It needs to be validated and normalized. It needs to be integrated with your CMMS, RCM, ERP applications, and then made available typically with APIs provided by your software application to users through robust data and workflow orchestration connected again through your enterprise asset management system. If we can go to the next slide, please. We'll talk about a few of the high value use cases that arise once you have collected this data. In the first case, it is actually instrumenting if the applications are not already instrumented, or collecting the sensor information if they are. Again, we referred to both wired and wireless sensors that now are typical across organizations. You have to deal with various industrial communication protocols and make sure that your software application will handle lots of different data sources. Excuse me. And then all this data needs to be validated for data quality and typically normalized for the sensor range that you're monitoring. Excuse me. So the high quality real-time sensor data that you can collect, this can include video data, vibration data, temperature and pressure data, and flow data. All of it will enable valuable anomaly detection and diagnostics. And because you're monitoring 24/7 with your automated devices, that means you're able to see the health of these applications in the field 24/7. You want to pass this data then to anomaly detection and diagnostic software that is normally built into applications like BCM Helix, where you can calculate simple KPIs that may be done on the edge devices, and also machine learning software that can be either on the edge devices or in the cloud. And machine learning software will detect anomalies sensor by sensor, machine by machine, pass them up to this single pane of glass where operators and engineers have real-time visibility to every application. And normally the types of early warning and performance calculations that can be done through today's software can provide hours, if not days or even weeks, of early warning of performance anomalies, in addition to diagnostics and sometimes root cause analysis and even prognostics. This means that your operators, instead of having to look at every asset in the field on a particularly hourly schedule, can focus on the assets that are really showing problems right now and spend time with the problem assets rather than spreading their time over a bunch of assets that mostly aren't having issues. So it can really make your operations and maintenance organizations much more effective. Maybe Sam, you can talk about process visibility and logistics management.
Thank you, Bill. That is awesome. So yeah, so when you look at the two other use cases, right, for process visibility and logistics management. So in the whole manufacturing process visibility is key, right? Because as you basically start like saying, how do I actually take a look at what is being done and what really is happening, right? And especially when you take a look at process, manufacturing, right? Like let's imagine, like I mentioned to you about the food processing plant, where conditions have to be met. The scenarios have to be whether it's safety, whether it's food regulations, right? Every industry, every manufacturing has that process requirements. So in here, basically what we are talking about in use cases, which is really combining the data that comes out from the different data points from the machine, and then really understanding, what that, you derive, information from the machine itself for what you're trying to do with, like, how do you bring the situation there? How do you actually do the real-time detection of any anomalies that may happen during the process, right? You cannot have that process basically run through its entirety and then basically have a remediation that you're doing or an anomaly that is detected, right? It has to be in real time. It has to be, and most importantly, it's got to be proactive than reactive, right? Naturally, reactive is a late stage, and you might not be able to step back from it. But so what we are looking at is, when we talk about process visibility, we need to actually understand how we actually pull that in prior to the fact. And the last part on this is logistics management, right? Logistics management is, as all of you guys are well aware, that there is a big a supply chain problem in the chain of events that are happening globally today. And so logistics management happens to be a key part of what manufacturing is all about, right? So we are also in the next few months, the BCM Helix IoT Edge is also going to be announcing what we are going to be positioning out to the market for fleet management. But this is part of not only the fleet management, but also about how do you actually transport the goods? What about inventory? What happens at the warehouse, right? How do you optimize, cargoes? How do you actually do the last mile delivery? How do you actually go out, and even what we are working with one of the vendors is on the planogram that happens in the retail industry, right? And so that tracks back into the logistics that is being delivered, from the manufacturing plant into the warehouse, into the actual store where it touches the hand of the consumer. So all of this is basically an important part of understanding and capturing the manufacturing details, right? Whether it's the process or it's the understanding of, like, really what happened in the warehouse, or it's about, things such as, like, how much inventory there is, what kind of shelf life that is, right? For food items, again, you need a shelf life. For non-food items, basically, there is a factor of saying what kind of conditions does it have to be, right? Does it have to be in cold storage? Does it have to be in normal storage? What have you, right? So what Bill talked about was the first two process on sensor integration and anomaly detection. And when I touch upon process visibility and logistics management, that is really the end-to-end of really what you're looking for in the manufacturing process. So let me move to the next slide. And Bill, I think you help us cover.
You bet, Sam. So we've talked about software for this whole webinar so far, but really the issue is getting the most value out of the resources of your manufacturing facility, and that starts with the people in the facility. Manufacturing facilities today focus greatly on hiring the best people and training those people as well as they can. But those people need visibility to their processes, and they need it end to end, as we just described in the last slide and the prior slides. So just want to reiterate at this point that to make your manufacturing just a world-class organization, you need to focus on end-to-end management of all your assets and all your software applications, so that they're integrated and they give you a complete view of your organization. Now, BMC and SimCon, as well as Deloitte and McKinsey, again, they've noticed that organizations that are striving to do this have increased availability to the range of 8 to 10% for their assets. They have 10 to 40% reductions in reactive maintenance, depending upon where they are on this curve of adopting this integrated ITOT platform. And because they're empowering their applications, their people with powerful applications that give them visibility to all the data, they see 10 to 15% improvement in labor productivity. So all of these are the hidden costs of not integrating IT and OT that we started out the presentation with. And I think everyone who's been following along can see how having this real-time visibility to all your processes can achieve the benefits that are listed here. We can go on to the next slide, and Sam, you can wrap this up.
Thank you, Bill. So yeah, and I think that is a very important slide, which is what you just talked about, Bill, right? The benefits of ITOT integration. Naturally, a lot of companies are very segregated. In my experience, operations is very segregated from IT, and IT basically has its own priorities and so on. And operations, mostly in many companies, run the business, right? Especially in manufacturing. And so the integration of bringing operation systems into IT is something that is of key importance into the whole schema of things, no matter what industry you're in, and especially when it talks about IoT, because naturally you're looking at things such as financial information, human information, and IT systems that are in place, and so on and so on. So thank you for sharing that, Bill. In this slide that you're seeing, which is for an invitation to co-innovation. So as you have heard about the challenges now on what basically IT and OT bring, and what really manufacturing brings into the mix, right? I don't think anybody is going to claim that this is a simple proposition. So here is really where we basically as BMC step in, right? The BMC Innovation Labs is a lab set up in multiple locations, a physical lab set up in multiple locations around the world, right? Starting from Houston to California, to Israel, to India, to parts of Europe, where we basically invite you, our customer, and potential customers, to come join us in this journey, right? We have expertise, and like Bill talked about, Bill is a manufacturing industry expert, and we work not only, we understand that this is a much bigger ecosystem, right? And so we as BMC have partnered with Simcon Digital in order to bring the manufacturing excellence up front. So we will continue to work with not only our software vendors, but also with our hardware vendors. We have close relationships with vendors such as Siemens, software organizations who run MES systems like SAP, software like IBM that runs asset management systems with Maximo, and so on. What we invite you to do is come innovate with us. Right? What innovation simply means is that we are not asking for what we're simply asking for is a workshop where we ideate together. And then once we ideate, we create an understanding of what your business use case is, what you're trying to derive. Like I showed you in the example on the screenshots from the demo that I was showing you, we actually create a digital replica or digital twin of your manufacturing plant. And then you are then able to actually take a look in real time on what your plant is, how it's behaving, and really how that integration is being done. And that actually all happens in the workshop. And from the workshop, we work together with your hardware vendors, with your software vendors, to create the prototype, create the proof of value, and then we commercialize it internally, right? And we invite you to be a partner in that journey of ours as well. So you can move to the next slide. So what we are extending an invitation to you, once again, as I said, is an invitation to co-innovate. Help us understand what your challenges are, what you're facing, and really come collaborate with BMC Innovation Lab. With that, I pass it back to Puneet for questions.
Yes, Sam, thank you. And thank you, Bill. I apologize on behalf of all of us to our attendees for the small technical difficulties that you may have noticed we've been experiencing, but it has been very fascinating listening to both you gentlemen. So I'm going to start with a question actually that, has been sparked in my mind based on what you both have discussed. And perhaps, Sam, you can take this. How will ITOT integration and convergence help in eliminating unplanned downtime?
Yeah, great questions that come in. So the downtime basically happens when the major thing is when IT doesn't talk to OT. Then you have the first instance of basically where you don't have coordination or collaboration between the two divisions, right? So how it eliminates downtime is if you have insights, right? Like I'll give you an example of one of the customers we're working with, and the insight is getting the human information into the manufacturing process, because naturally there is a human that sits at the manufacturing process, understanding his skills, understanding the behaviors that he's putting together, how fast is he able to move between the different processes that are in place. So that allows us to really, optimize that process of manufacturing for that station, for that human being, right? So that actually is something that we work with. And so this is just one example of how really this integration has allowed us to reduce the downtime with manufacturing.
Great. Bill, you mentioned something about predictive maintenance. How does predictive maintenance, the predictive maintenance use case, how does that create value?
Well, a good predictive maintenance strategy creates value by improving equipment uptime, reducing maintenance repair costs, improving the ability to predict production run success, and improving the winning culture of the plant team. These benefits are driven by shifting unplanned maintenance to planned, and by being able to predict asset performance for the duration of a production run. Predictive maintenance allows asset teams to be able to identify equipment problems early enough to develop a maintenance plan, to localize the problem on the equipment, and to increase the confidence in correct problem diagnosis, so that aids in rapid, cost-effective repair. When your maintenance team has a good idea of what the issue is, where it's located on the equipment, how severe it is, they can attack the problem with the right tools and the right resources.
So what should be the first steps in the predictive maintenance journey then?
Well, the first steps in the predictive maintenance journey, I think, need to start with a strategy at the corporate level, or certainly at least at the plant level, to decide what your critical issues are and what resources you're willing to invest in them, and what kind of calendar time you're willing to commit those resources to in order to attack the problem. I think at that point, once you've made the commitment, you probably want to look for some sort of partner, such as BMC or SimCon, who have experience with these problems over many, many types of manufacturing facilities, and have addressed that problem with problem-specific types of software, with the ability to add instrumentation to problem assets, with the ability to collect data in real time and feed it up into either your existing monitoring applications, or maybe new applications provided by the software vendor. But it really begins at the high level with that commitment to certain resources and certain period of time you're willing to attack the problem.
Awesome. Well, thank you, Bill. Hey, Sam, what are your recommendations on how IT and OT need to work together?
So the major recommendations in my perspective is really the ability for us to start with understanding your operations, right? And then also take a look at what IT processes that you have. Take a look at where the separation of these processes is, right? I mean, naturally, there's a finance department, of course, there's accounting, and there's, as I mentioned, HR, and then you have a systems of record that are there, traditional system of records. And then you're collecting data from operations, right? And this is really from the field. If you're collecting data from the field in operations, then you need to understand what those gaps are. How do you fill those gaps when you take it and you want to merge that data into IT? And so understanding, what your processes are, where they differ, and really how you can optimize these processes in the overall scheme of integration, I think is a great start to the ITOT integrations.
And so what are some best practices for IT teams as they go down this road? Best practices for them to work with operations?
Yeah, so great question, right? So some of the best practices, in my view, are the ability for, really have like normal cadence, right? With the operations team, because I can tell you again, like based from my experience, they are completely siloed in many, many organizations. And if you yourself are a manufacturing organization, you know this as a fact, that your operations is completely siloed. And even in operations, there are multi-silos that are happening, right? IT as an organization, in many ways.
Let me just add one thing to what Sam said about this. In working with many, many different types of organizations at the corporate level to address plant-by-plant issues, I found that it's always a really great idea to choose an early adopter plant to begin a strategy that you want to apply corporate-wide. This early adopter plant has the right management, the right engineering staff, and the right culture to try something new, deal with the inevitable frustrations of starting something new, and then seeing it through to the end to make sure that you get the best result for your culture. Now, once you've applied it to the early adopters, there can be challenges with the rest of the organization, of course, but you'll learn important lessons by starting with the early adopters that you can apply throughout all the other plants that you may have.
Awesome. Thank you, Bill. Anu, how are we doing for time? Can we squeeze in another question or two?
We can, yes.
Okay, thank you so much. Actually, there's a question that has come through from our audience. Perhaps, Sam, this is a question for you to answer. Are you working with any automation technology providers, as asked by one of our attendees? Repeat the question.
Yeah, so are we working?
Are you working with any automation technology providers?
Correct. So, yeah, we need a little more clarification, but if I'm not mistaken, I think the question is, are we working with any automation vendors, right? I mean, automation can take different forms. Automation can take a form of RPA vendors, right, which are basically doing robotic process automation, or it could take the meaning of actually hardware automation, right, where actually hardware basically interacts based on a base workflow, right, that is executed and fired up.
Sam, a clarification has been provided by the person asking the question. They are saying they mean like PLC manufacturers. Are we working with any of them?
Okay, got you. Yeah. So when you're talking about PLC, then that's a whole different area of automation, right? So yes, we are, right? So we are working with PLC automation, right? Because naturally PLCs are tied to basically processes that, or equipment, right, in the plant itself to the sensors. The PLC is tied to the sensor, which can invoke an action on a particular process that is happening, or a particular, manufacturing equipment that's happening. And also, naturally, we work with, automation at the probably at the DCS level, right, which is a lot more automated and has a lot more intertwined systems, in it, right, because you're talking about a much bigger subsystem that is out in place, right? So you talk about automation that can happen at a singular level or at much more sort of joint level at the DCS system. But yes, we are working with specific vendors like the Siemens of the world, where we are talking about how we actually automate within that process.
Thank you, Sam. I think we are getting close to the end of time. So, Bill, any parting words that you'd like to share with our audience?
I guess what I would say is, just to recap, that we've tried to show that where companies are today is normally short of where they want to be, and that companies like BMC and SIMCON have the ability to take all layers of the manufacturing plant, all levels of the corporation, and tie those together from the machine level, where they can add sensors, connect machine sensors to edge devices, connect edge devices together, connect the aggregated devices to the cloud, and then provide analytics throughout that stack of important applications to provide real-time view of information that facilitates the good work that their key plant engineering and maintenance personnel are trying to do today.
Thank you, Bill. Sam, it is obviously very clear from this discussion that OT-IT convergence matters. Any additional, final thoughts before we close out today's session?
Yeah, and my final thoughts are in the fact that it is not only about ITOT integration, but it is also about the ecosystem, right, that you work in, right? So naturally, there are IT vendors, there are OT vendors, and the most important element between the two is the human factor, right? So it has to have encompassing views where basically you take the technologies and the two sides together, and then how does the human element work in this? Naturally, humans are the center point of any manufacturing or industrial 4.0 initiative, or as think about this, as you digitally transform your manufacturing process, think about all of the things that are important, and work with your reach out on the other side of the aisle to your IT or to your OT. And then, of course, BMC has this expertise that it has done so amazingly well in IT. And now with our interference in OT, vendors like us are going to be key to actually, do that handshake between the two. So thank you.
No, thank you, Sam. Well, folks, we're almost at the end of time. I thank Bill and I thank Sam for their insights. Today, we have learned about BMC Helix IoT Edge. We've learned about OT and IT convergence, which is very important. We've heard about the advantages of a unified IT/OT platform. So, folks, I thank you very much for your time. Thank you for being with us for a good part of an hour. But before you go, I'd like to tell you that if you enjoyed this session today, mark your calendars, because there is another webinar coming as part of this series. It will be on Thursday, April 7 at the same time. Stay tuned for details via email, LinkedIn, and Twitter. Until then, stay safe, stay healthy, and now go ideate, go create, and you know who to call if you need to co-innovate. Thank you. Have a great day.
Thank you.